Alright, I'd like to make a quick video about how I'm building Raspberry Pi, control on a Raspberry Pi. And I made the initial description on the controller forum a few years ago now. And so a couple of things are different. On the Mate I used to build, I could use this normal brace, and I need to use curly braces. So what I'll do is I'll go through the steps and then I will update them. So here we go. We want to export. There's a problem. Look, we want to export that thing, don't we? Because if we don't export it, it won't know what that means. So that's the first thing we do is edit, copy, buff, bang, paste, and there we are. Then we want to mkdir that and cd ... copy. Oh no, we don't. We actually want to mkdir that. We want a cd pling $, and then we want to do that. That would be a much better set of operations to do, wouldn't it? So we've defined the variable. We're going to make it. We're going to cd to it. Pling $ means the last command. Then we go up one, and we're going to git clone. So that's what we're actually going to do. So let's just pick all that stuff up. Copy. Move into here, Shift Control V, we'll paste the commands in, and it will start running, and we'll discuss what we're doing in the background whilst this pulls down. So what I did was I looked through the software and I found what it needed in terms of packages for Ubuntu. So it needed things like G++, and at the time of compilation it was using 4.8, and now we're on 8.3 or something like that, and all these various packages. I might hit some problems because I'm using the Mesa, and my libxrandr-dev is one I built from well, it's been checked into the Pi branch now. So I was using the experimental Vulkan drivers. Now I'm on the latest 20.1, I think. So you'd run this. I'm not going to run it because I've already done that. Then we've got to go to the controller directory, and we've got to check out to a certain known point in time, and it was Atom. Not Archangel that found this specific hack. Somewhere I'll give him credit for it. I do like giving people credit. It'd be nice if they did it back occasionally the other way. Yeah, there we are, Archangel. So he was the guy that did this. So let's let that come down. And what we'll do, I'll briefly go over it and then I'll come back into here. If you was on a Raspberry Pi, you only have 1 gig of RAM, so you need to set up a swap file, and you need a decently fast micro SD card or a nice USB controller to run a disk. Yeah, and then you have modified the build script a little bit. What I did in one incarnation, I actually created a Raspberry Pi target. And what thing that's crazy here, these two files are the same, and we'll cover that in a moment. Then what you would do is you'd edit the make files, and I'll go on to why we do that. So they're not quite right, and there's a few more things we need to do in my opinion. Then you copy some binaries across, which you've already just pulled down with the sudo apt-gets. And once you've done that, then we can begin to build it. And so let's see to where we got to. Now we want to go to controller and git check out this software. So let's just edit copy. Pardon me, that's a sneeze. I don't have COVID. My wife's been cleaning, and she's settled the dust everywhere. So there we are. Now we can cd to $controller root, which I don't think we need to do because I think we're actually in the same place, but we'll do it all the same. There we are. So we would find where the build scripts are. Edit, copy, Control-Shift-V, and there they are. But if we do an ls-l of the VST one at random, we can see it's link -s. So when we vim that one, we're actually editing the same file. And you see the build dir is set here. And this represents some problem because now you end up clashing two binaries in the same build place. Now the other thing, perversely, you see there are 4 processes here. I have no idea why they're busy at the minute. And so if we have more than or equal to 4, we get 1. Otherwise we get 2. That's just plain dumb. And we've got the processing power, so we'll just make that 4. Okay. Now we need to find this line here, And what you can see if you look at them, just edit copy that. What? I want to edit copy that. Come on. What there was a couple of directories missing. So, oh, sorry, a couple of include paths missing. So we DD that, we open that, we Control-Shift-V that in, and we remove that line there, and we're good. We've done that. And because it's common to the two, what have we done common? We've got the same build path. We're going to use 4 in the job, and we've included the extra missing include files required to build the Juice. So we can exit that. Now we have to edit the make files, and they're individual. So go back to the find, which is up here, and we'll look for make file. And there's 3, but there's only 2 we actually want to edit. So let's find them. There they are. So we'll do the standalone first, vim standalone, and then we'll edit the VST. And if we go to the top, let's do something kinky first. So you see, it's always going to build in build. Doesn't matter what you do. And 2 things we need to change. We need to add an extra define on the define path, and we'll do that in a moment. And then you see every so often it has these kind of crazy underbar and a series of 7 or 8 digits. Here we are. That tell it about stuff. And I can see why it does it now, because now you have a control OS that's being built from this version with the standalone, so it won't clash with the different number from the VST. But I just prefer, you don't need to do this, but I prefer to do this. So I prefer to say, hey guy, go throughout the whole file and go replace Control V, go replace 8 characters /.o. So /dot means a physical dot with underbar SA for standalone. So we do that. And then I want to do the same thing again, Control-Shift-V, but this time it's 6 digits and an O, and that picks up the spares. I was just hesitating for a second because I've already changed that, but of course it's just a target, so that's fine. I don't want to Control M, do I? That can disappear. And that's done that. And the standalone version, if we look at the end for the go to the back, question target, question target even, it's capitals, it creates the build command here, and the build command, if we hash to it, is cxx minus output blah blah target, and the target is Ctrl-Arch. Now what I found is that there is a Ctrl-VST, so we're good for that. So now the only thing missing, we go to the top, we find the C flags space, and then let's do 10W to move 10 words, and we insert -D, have underbar L round equals 1. I don't think we need equals 1, but we'll put it in all the same. And there are 3 targets, debug, release, nightly release. So we move to the next one. And again, we go 10W to move 10 words. We do dot because we can recall it. Escape, N for next, 10W, dot, escape, and if we look for next, we're back around the circle. So now we can write that file, and now we can move the :N to the next file. Because we're in the middle of doing that process, we may as well continue look for the next. So it's still in the buffer. So again, 10W dot, and this is the lovely thing I like about Unix or old school Unix, is you can just do this. So escape next, 10W dot, escape next, 10W dot, and so now I go to the top and I want to do the business where this time I'm changing things to VST. So if I get all that lot, please turn it into VST. So I copy that and I do Shift Control V, remove the /M, I hit that, and then I go and I do its little friend here, which has got slightly less content in it. Again, I don't know why there's 7 and 8 digit things. You don't need to do this, but I think it's just slightly neater. So that's that. So we've done that, okay. Now we need to find these, we need to find the libraries, because we just installed with the sudo command let's get it in. We just, so it needs this sort of libbfd, it needs the liberty and whatever. So you see that one, we found it in user libarm blah blah blah. That's the same. So I think these exist. Let's just have a quick look. Well, let's give it a go. Look, come on. So we want to copy the libfd, the libibity, I don't know how you say that. So Shift Control V. Yeah, that's worked. Good. So we got them in there, and these are needed for the link. And now we want to go to the scripts, copy. So edit, paste. You get to my age, remembering stuff is difficult. So now we vim the post commit script. Let's have a quick look at it. Whenever you're dealing with shell, it's always a good idea to go to the end, because this seems to be where things happen. So you've got the detect OS and the build now. When we look at the detect OS, it's got a choice of Windows, Linux, and we think we're Linux. What I did in another incarnation, but I could never quite check it into the Git, because I wasn't certain how to get the CMake stuff to work. I defined a Raspberry Pi, and I had an RP, and I think that was a cleaner way of doing it. And I think, you know, if ever this went into some main branch, it'd be nice to have a separate Raspberry Pi one. But you see the build now says, okay, build now Linux. Yeah, if we hash that, takes us to this. So it's going to basically remove some cruft, and then it's going to unpack the boost library and then build the pre-compiled headers, and those used to take a long time. Then it tries to build the standalone and then the VST. So this takes a little while. I'll just set it off running, and then it strips the binaries. And if you debug, I don't think you want to do that, because the whole point of debugging is you want the symbol table, and I needed that in order to debug a problem with the build. The first time I did it, it doesn't seem to manifest anymore, so I think something might have been fixed in the Linux layer, but let's see if we get that far. So let's have a quick look at what the system's doing. At rest, it's using 858 meg and a fair amount of processing, which might just be the video, the simple screen recorder, I don't know. But let's just run the post. Oh, and it's going to put it in the build generated Linux, and it's going to put it in the build command. So let's just pull up an xterm in the background, and let's cd to controller builds. Control, I thought it was builds. Oh yeah, generated. And what we'll do is I'll make that a little bit smaller, and I'll just start this thing off, and then I'll pause the video in a minute because it will take a while to run. So post commit, and this should now go through. It's expanding out the boost, and then it's going to try and start building. So any minute now, I expect to see some directory being built here. Maybe it's already under Linux actually. So this pre-compiled headers, now you see it starting to use 1.3 gig. So this is why I demonstrate, or said you need a swap file on a Raspberry Pi, because you've run out of memory big time already here, and you're stuck. The cross compiler, I gave it 2 gig, and it was much better. I really don't know why. The Linux cross compiler was a much nicer build, but this is going to get up. I've done this a couple of times. It's going to get up past 4 gigabytes. So I think even if you had a 4 gig Pi, you'd struggle. I think you wouldn't struggle to run the build, but to do the build, I think you'd struggle. So an 8 gig would be pretty cool to have lying around as your build master. And actually for my application, which I'll hopefully produce a video on later on over this holiday period, I'll probably go back to using the Raspberry 3, because I just want it to be a controller of some sort of pedal, and it doesn't need to be doing that much. But we've already gone past the 2 gig Raspberry Pi, so we'll be in trouble at this point. And let's just see, has it created these directories? Tail -f controller ARM. This will just be telling us what's on that left window. So far, I see. Oh, here we are. Look, building for ARM, compile PCH, and then it should actually start to kick in. And then we should get all 4 processors busy, and it will really start to whack this thing. That's the theory. I don't know what it's up to. Let's see. Okay. Generate. Oh, yeah. No, yeah. So now it's compiling. Let's just wait for the first set. It should be in generated build, because what should be changing our build. There we are. ARM. There we are. ls-l. So that's what it's trying to do. So 4 have gone in. Each processor is busy. Eventually, one of these will come out, and then we'll have something written into this file space. That's my theory. Maybe I screwed it up. So we're on 100%, 4.5 gig or 4.3 gig. So you're going to be struggling on your 4 gig Pi. Then again, you wouldn't be videoing at the same time, so maybe not so much. I don't know. But I think, you know, for the extra money for the 8 gig, I think it's worth it for these sorts of things. Here we are. So now you see we've got SA for standalone. So this shows that we've got the same combined directory, but now the D file is the dependency analysis information coming out of a make. For those old enough to remember how make works, it tries to understand, based on the rules that you give it or the rules it determines, either or, it tries to work out what target depends on what sub-target. And so if you make a change to one file, it may only need to just do a very simple rebuild. But if that one file is shared in every single binary, it has to rebuild every single compilation unit and then relink. Yeah. So you'll start to see these things coming out here. And then when the VST comes in, I expect to see underbar VST. Now, normally you'd see these numbers or prefixes, postfixes generated by producer. I don't really know what producer does. Cool stuff it does, but I don't like the way it does the other stuff because I want to know this is from an SA. Yeah. And the other thing is that if you make a mistake, as I've done a couple of times a day, and something doesn't build, like I forgot to copy the libites and those things, be advised to go into the build shell and remove the rm-rf, because otherwise it's going to basically remove all this stuff you just built, and the one link, which is a link, is irrelevant from the perspective of building the sub-target. It's just a link. All that work that you've done has been undone, and it's about half an hour's worth of work, yeah. And you really don't want to do that. So I'll leave it running, and I'll just pause this if I remember how to, and then I'll come back after I've had a cup of tea. I think I won't have the beer tonight, but a cup of tea. So okay, I'll be back. So I'll just unpause it at this part, because here you see we got to the Juice audio stuff, and this is where things would have crashed, because if you look at the Juice, it has these hash includes of other files, and the CPPs include some C files, and this is where without the -d have L round, we would have hit some sort of problem. So that's the reason why you did that. If you don't want to believe me, just play without it and you'll see the later compiler will fail. But anyway, yeah. Okay, now we're getting to the stage where it's linking. Let's see how many we've compiled so far. 442. Build succeeded. Okay, where did it put it? LSC, wasn't it? C something? That wasn't very good, was it? LSC star arm star. Nope. So now it's going through doing the same for the, I think it puts it dot bin, wasn't it? Can't be there. Oh, there is a bin there, look. ls, oh, controller arm. ls-l. cp, okay. So whilst that's running and we're using a lot of RAM here, let's just make certain we're definitely recording, yeah. Okay, let's just try and run /controller arm then. La, 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 la. It's a bit unfair because we've got 2 gig used and we're using a lot of. Oh, it's over here. Look, sorry, it's over there. There we are. So it's done something a bit crazy there, but there it is. So all right, let's try and can we refresh this? Is there a refresh Windows button? Oh man, there used to be a refresh Windows button. I want to leave that running. Yeah, I think we're using quite a lot of. I'll do that again. I think we're using quite a lot of processing power there, and things are a bit confused. Control C that. Die. Probably should have waited for it to finish doing what it was doing. I got a bit too ambitious. Let's open the X term here. Oh, it is the X term. Okay. Now let's open one of these a second. Come on, you can do this. The Pi is obviously a bit busy. Oh, here we are. About 10 of them turn up at once, like waiting for a London bus. Okay. There we are, because it was doing the unpack. So, and now it's finished. I think it's killed itself. Okay, let's try it one more time, because it was obviously in the middle of something a bit kinky. There we are. So, oh look, it's got a panel. This is the panel I made for the K1R. So it obviously stored this somewhere. So what I did is I went to my controller here, Miniac Tools, where I store Miniac stuff, and I brought down the BZ panel to the downloads, and then when you come to open a panel, you tell it you want to open a panel, and you've got a drop down somewhere. Here it comes. So you see down here you can choose the different types, and it was a BZ panel, so this is a zip panel. So we'll just cancel that off. It's working. Well, at least it's showing this stuff. So now that's pretty cool. So my next thing I want to do with this is start to play with the touch panel I bought. Is that working? Yay! That's pretty cool. That's working. Okay, I can use those. Yeah, they work. Good. So I'm hoping that the touch panel will let me just do this with fingers. I'm not quite certain how you can use the control and the middle button to make stuff bigger and smaller. So I might need to think about the layout to get it about right, or there might be a way of setting it. Because I just wanted to get slightly bigger than that. Maybe I can do Control Shift Plus. No. Yeah, so this one should write to the file system. Okay. That should make a piano. We're not connected it. Those should be the sliders. They all seem to work quite nicely. That will say loading. Okay. And what's on the singles? Yeah, that looks okay. It's sort of come through. So that's not too bad. I can sort of read that. Little bit to be guessed, or you can just type values in like 22. Okay, that's looking pretty good. I guess all of the, has it got the programs in there? Panel mode, you turn it off, panel mode, don't you? And then this lot turns up. Can I click on that? Will it show me the Lua code? Edit, where's the Lua code? Oh, there, Lua editor. Has the code come through? Yeah, it has, cool. So all my code is in, that's good. So I'll be doing a similar thing with the zoom pedals. Although there's a bit more to be done for those, so I need to think a little bit about how it will work, but that'll give me something to do over the Christmas period or whatever holiday you're in at this time of year. Okay, so let's file, exit that. I'm not quite sure why the fonts are so big. I might have to do a little bit of reading about that. But yeah, 5.4 built today. Looks pretty good to me. That's okay. I think I will have a bit of fun with this. So I think what I'll do is I'll pause. Oh yeah, I'll pause and let that run. But now we want to pop directory, or we didn't push directory. We want to go back to, where was it? Build generated Linux standalone. No, it would be build, wouldn't it? Yeah, there we are. ARM, and then in this directory. Oh, interesting. So you see, I see what I didn't realize that. So what it did, of course, it makes sense as RM-F. So So actually, what I said about that business with the underbars and all those crazy names, it's irrelevant because it deletes it all anyway. So actually, I thought if I did it this way, I'd have the underbar SA for standalone, which we saw, and I'd have the VSTs, but it's just removed them all. So it's actually a kind of crazy way of, I can see why they've done it, but it'd be better to have a separate directory for the simple reason that you could have independent builds in parallel. So ls-1 pipes into word count minus l, 48, so divide by 2 because we've got 24. So it's going to take a while to build. So I think what I won't do is I won't bother. I'll stop the video at this point. Let's go back to what I did, and I'll put this in the description. So basically, I go to the page where I'd written about this in the first place. I create an export route. I have to use this normal Unix version. I still don't know why I used the curly braces last time. I cd to that directory. I go up one. I git clone in. I unpack various sort of libraries that you need for development. I go to Ctrlr. I check out a unknown point thanks to Archangel. Then I go into the directory and I find where the build shell is, and we notice that there's one that's on both of the symlinks. Then I go through each of the builds, I edit the thing, I give it 4 jobs because the Pi4 with 8 gig can handle it. I go to about line 14 it is, and I change the G++ to be this because there's a couple of extra include directories that are needed. Then I go in the make files where they exist. I add the seed flags to have the have L round 1, and I modify these. You don't need to do this, so it's probably not worth doing that. Yeah. Then I go and find out where the libbfd is and where the libibity is. And I copy those into the respective places that are going to be required for the builds. Then we go to the script and we run the post commit and take about half an hour and you should have a build. In the past there was a problem with the startup and you had to go and change a setting. Now the setting was something that said worse to the effect of don't use a particular Linux library in order to open something, but that seems to have been fixed because this is a completely brand new build. You know, if you go from, you can't move from a Pi3 to Pi4, you need a brand new memory card or whatever you're building on. So I couldn't possibly have inherited anything from the previous fix where I had to change something on the file system. So it looks like Linux have made or Pi has made the fix and it just works. So yeah, hopefully you'll enjoy that and take care and have fun and bye-bye.